Hello, my math friends. This is Mrs. Schlecht, and in this video, we're going to go over simplifying algebraic expressions. All right, my friends, so you know there's a few materials you need in order to be successful for this activity. First, you're going to need your Envision book with our robot friend on the front. Second, you're going to need your math notebook so you can take those great notes and show your thinking. Third, you're going to need that pencil to take those notes. And fourth, last but never, ever, ever least, that positive math attitude. Okay, so this video goes really well with lesson 3-7. And like I said, what we're doing is we're going to be looking at big, long algebraic expressions, and we're going to simplify them. We're going to make them a little short and sweet without changing the value of anything. All right, so the key concepts page for this lesson is on page 170. Okay, so before we get into all like the super cool, fun math, I want to talk about this term right here, like terms. What this means is if you have a coefficient with a variable, every time that you have that same variable, those are like terms. This is what I mean. So let's look at this simple expression. We have 4y plus 7y minus 3. Now notice that this is a coefficient with a variable, this is a coefficient with a variable, and it's the same variable, which makes them like terms. Notice that our lonely 3 is just a 3 hanging out by itself. It does not have a variable, friend, which is just so sad. But that means it's not a like term. So in this example, my friends, if I was trying to combine like terms in order to simplify it, essentially what I'm trying to say is, hey, how many y's do I actually have? I have 4 y's over here, and then I have 7 more y's over here. So let's see, 7, 8, 9, 10, 11. That means that if I combined these two terms, my friends, I would actually have 11 groups of y that I'm trying to multiply. But since there's no like term that matches with this minus 3 over here, that's just going to stay the same. So if I were to simplify this expression, it would look like this, 11y minus 3, all right? Again, my friends, I did not change the value right here and right here, same values, right? No matter what y would be. All I did was I simplified it. I kind of made a shortcut, right? So that it's easier for me to solve instead of all of these steps, right? The idea behind this lesson, my friends, is to make your life easier and to take big old long expressions and simplify them, make them simpler so that we can do those operations and perform that math. All right, my friends, so the first problem that I want to look at together is page 170, number 7. And the expression that it first gives us is 4y minus y, and it's asking us to simplify that. Oh my goodness, super easy peasy lemon squeezy, my friends. Think about it like this. If I have 4 y's, but then I'm taking one of those y's away, well, how many y's do I actually have? So an equivalent expression for this would just be 3y, right? So we learned that 4y minus y is equivalent or the same as 3y. And if you don't believe me, let's just give a value to y. Let's just say that y is equal to 2, because why not, right? So if I had 4 times 2, that's 8, minus 2, that would be 6. Would that make sense over here? If I have 3 times 2, is that also going to give me 6? Yeah, it totally is. So again, my friends, we just simplified and created an equivalent expression. Now let's look at still page 170, but number 8. All right, here's our example for number 8. We have 7y minus 4.5 minus 6y. Now, like we talked about with like terms, my friends, since 4.5 does not have a variable, it doesn't have that y, this is not one of those like terms. So this is going to stay as it is because remember, we are not changing the value of any of these expressions. We're just simplifying it, we're just changing the look, okay? So since 4.5 doesn't have any buddies, that's just going to stay the same. So now let's look at this. We have 7y, and then I'm going to be taking 6 of those y's away. So how many y's would I have left? We would only have 1 y left. Way to go. And remember, we're still subtracting 4.5 because since this was not a like term, I can't combine it with anything, right? I can't simplify it. And we have to make sure that we still have that piece, my friends, so that our value stays the same. So we know that 7y minus 4.5 minus 6y is equivalent or equal to y minus 4.5. Okay, so the next problem that I want to look at is still on page 170, but it's number 14. And the reason that I want to look at this one is because it has fractions in it, but that's okay. I want to show you that fractions is nothing to be afraid of, right? Same process, same, everything still applies. Remember, my friends, we're not actually solving these equations quite yet because I don't have enough information. We're just trying to simplify them, okay? So let's look at what we have. We have 3/4 x. So yeah, coefficients can also be fractions. Cool, okay? So 3/4 x, right? Plus 2, that's just a whole number 2, no variables, just 2, plus 3x, so there's that same variable, minus 1/2. Now notice a couple different things, right? We have a coefficient with a variable here, we have a coefficient with a variable over here, and then we have just some numbers, right? We have 2 and we have a negative 1/2, or essentially 2 minus 1/2. Now, my friends, those are like terms, okay? They don't have a coefficient. They're just like numbers that I can still add and subtract together, okay? So x and x, right, with those variables, those are like terms because they're alike, right? We're multiplying it by the same variable. But if it's just a number, if it doesn't have a coefficient with it, it doesn't have that variable, then those are still like terms and you can still add or subtract whatever you need to do. So let's start looking at this. So I notice that I have 3/4 x and 3x. So let's think, how many x's do we have all together? Hint, it's going to be a mixed number. Check it out. So for the first piece, my friends, if we have 3/4 plus 3, think of just your regular addition skills. That's going to be 3 and 3/4, right? We're going to have a mixed number. And don't forget about your variable because we were combining those like terms, correct? So in order to start simplifying some of this, I know that the first piece, my new coefficient with my variable, is going to be 3 and 3/4. But we're not done quite yet because remember, we said that 2 and 1/2, those are also like terms. So think about it. If I have a positive 2 and then I subtract 1/2, what would I actually be adding? I would actually only be adding 1.5, right? Because if I take half away from 2, I just have 1.5 left. So my friends, you just tackled an expression that had fractions in it, and you did it, which was so great, okay? So we went from 3/4 x plus 2 plus 3x minus 1/2, and we simplified that. We made it easier for ourselves, and we figured out that it's actually equivalent to 3 and 3/4 x plus 1.5. Again, my friends, same value right here, just a different look. All right, my friends. So the last one that we're going to look at together is on page 171, and it's number 16. Now, the reason I chose this one is it doesn't have fractions, but it has an exponent, but you can still do it, right? You can still do it. So notice that our variable, which is x in this expression, is actually x to the second power, right? It's x squared. That becomes a term, my friends, right? This becomes like a unit that needs to stay with it, okay? So we have 2 and 1/10 times x squared plus 3 minus half times x squared minus 1. So just like in that last example, we have coefficients that are like terms, and then we also just have regular old numbers. Those are also like terms. So now, my friends, let's start combining these, all right? But I'm going to use some grouping symbols. So I think what I'm going to do is I want to put my like terms together and then my other like terms together. All right, my friends, so all I did with this first step is I just rewrote it using parentheses, but then putting those like terms together, okay? So I know that we have 2 and 1/10 x squared minus half x squared. Notice that it was actually like adding 3 after that, but remember we're combining those like terms. And since we were going to be subtracting this half, that's actually the same as saying it's a negative number, right? So I got the negative sign or the minus sign right from that problem, okay? And likewise, my friends, why am I adding this parenthesis? because that's what the operation was right here, right? But I pulled all of my like terms together, and yes, I'm adding whatever is in this parenthesis, but notice I'm subtracting that one. Again, that came from that problem. So we're changing the look, right? But not the value of it, my friends. That's why it's so super important that you keep these operation signs in the correct order. So now that we have these all lined up with our correct terms or our like terms, now we can start simplifying it. So think to yourself, if I have 2 and 1/10 and then I'm taking away half, what would that be? And likewise, if I have 3 and I minus 1, what would that be? Our final simplified expression would look like this: 1 and 6/10 x or x squared, right? X to that second power plus 2. So again, my friends, this is like the superest, like coolest thing in math, I think, is that we went from like this really big, long, complicated looking algebraic expression. We were able to simplify it and whittle it down until we got a simplified version of it, but it's all the same value, right? And if you don't believe me, just create a value for x and then see how it's correct. My friends, so that was just a quick walkthrough of lesson 3-7, which helped us learn how to simplify these algebraic expressions. If you have any other questions, please let me know.